Hi everyone, this is an action-packed video in which we are talking about a complete step-by-step roadmap that you can follow to become a data scientist. Everything from the technology you need to learn to the free and the paid resources and how to get opportunities to become a data scientist, work at big tech companies or at startups. To tell you about all of this, I have invited someone who has in-depth experience about this field, has been working as a data scientist and has taught hundreds and thousands of students just like you about this field. If that sounds exciting, make sure that you hit the like button and subscribe to this channel, and let's welcome Srikanth in this video. Hi Srikanth, thank you so much for joining me here for this podcast. How are you doing there?
Things are good, things are good. Just cloudy weather, but otherwise things are good.
We had a wonderful conversation before shooting this. Just to the audience who's watching this video, tell us a bit about your past experience of working in this field of DSML and how did you get got started?
Hi, my name is Srikanth Varma. I'm currently one of the instructors at Scalar, and I'm also responsible for the design of curriculum and the whole academic experience at Scalar. Prior to this, I was a co-founder of a startup called Applied AI Codes and Applied Roots. Which I started around late 2017. Currently, I still manage Applied AI Codes and Applied Roots. We have few tens of thousands of students that we work with in upskilling them in AI, data science, software development, etc. Prior to that, I worked at Amazon for about 5 years, both as a machine learning scientist and also a senior scientist and lead, both out of their Bangalore office and their Palo Alto offices. And that's been one of the most interesting experiences because I got a very front row seat of actually building machine learning applications from ground up for the whole advertising org of Amazon. I mean, that was a terrific 5 years experience for me. And prior to Amazon, I did a computer vision startup. It was a failed startup, but a very great learning experience because I learned how not to do a startup. And prior to the computer vision startup, I worked as a research engineer at Yahoo Labs for about 18 months. And one of the things that I told my manager then was, I don't think my kids will ever hear of this company called Yahoo because you guys are clueless on what you're doing. And prior to that, I was at Indian Institute of Science studying machine learning and AI for about 2 years. Prior to that, I was doing my undergrad studies in one of the smallest engineering colleges probably in the world at that point of time. I know this because I was the first batch in the engineering college. And my interest of data science machine learning started somewhere around my late third year, early fourth year of undergrad because I started reading digital image processing, which was an elective.
Year is
this was 2006. Yeah, 2006 was when I was in my third year, the transition between third to final year of BTech. And in my third year, I got a very good gate rank. So I said, let me explore things now. So I started learning digital image processing. I picked up a book on artificial neural networks. I didn't know what was happening under the hood, but I know how to code. I just coded things up and I thought, this is the closest to magic that there is. And then I was fortunate enough to get a very good gate rank that took me to Indian Institute of Science. At Indian Institute of Science, I had the best faculty that India could offer for me to learn AI machine learning. I went to my professor on the very first week and I told him, I want to learn this thing called AI. He gave me a list of math courses and he said, learn all this and then come back to me. So my journey started because I experimented with it through a bunch of electives in my final year and it felt the closest to magic. And even now, when I use things like, let's say, the first time I read the Dall-E paper or the image gen paper from Google, which is behind stable diffusion, you know all the math, like I understand the math, but when I actually see it happening, it still feels like magic.
What is Dall-E to the audience that is just...
Oh, yes. So Dall-E, stable diffusion, image gen, all these are ideas wherein you can give a text prompt and it generates a very high quality image out of it. All through, just using the brute force of data on the internet and a bunch of very, very smart algorithms. So I can say Ishan and Varma sitting across a sofa and talking to each other. And if it knows who Ishan is, if it has a bunch of videos of you from YouTube, bunch of photos of me from Google, it can create that image, literally. If it knows who Ishan is and who Varma is. And that's the power of, that's literally the bleeding edge, most beautiful, elegant incarnation of modern AI.
That's really interesting. We'll talk about this in the later part of this podcast. But like, what is data science in its core and how can someone get started in this field? That's a very common question that my audience has asked me multiple times.
So let's break it into two parts. What is data science? So the two parts, the name itself is self-evident. What is science? Science is about experimenting, observing and coming up with conclusions and building things around it. That's the science part of it. Whether it's physics, chemistry, you make a bunch of observations, you take in all the observations, you build theory around it, and you can predict what will happen in the future. The physics part of science is about understanding natural phenomena. The chemistry part of it is at the molecular level, typically. The data science thing is, how do you take raw data? The data could come from astronomy, it could come from biological phenomena, It could come from ecological phenomenon. It could come from chemical reactions for all you know. The data could come from anywhere. Doesn't matter for me. How do you take the data? How do you use scientific methods like A/B testing, like actual scientific rigor? How do you use mathematics to make sense out of the data? So data science is all about how do you use everything that science knows? Right. Whether the concept exists in engineering, science, engineering, physics, mathematics, I don't care. How do you use all of these tricks that we know? Of course, computation being one of the most important things. You're given data, how do you make sense out of it? That's what is data science. Right. That's the first part. How do you get started in data science? Of course. See, the data science itself has, as the name suggests, right? You have to know how to process data. You have to know how to handle data. And the best field of science or best field of engineering to do that is computer science. Because we are damn good at tackling petabytes of data. So you need to know basic computational principles like programming. How do you get data? How do you write simple SQL queries? How do you pre-process data? How do you do simple plotting, right? So to get started in data science, you certainly need some computational tools. Again, you don't have to be an expert software developer. You don't have to know high-level design, system design, all that. But you have to know the basic tools required to process data. That's it. That's where the data part comes. Now let's take the science part. The most important tool in science certainly is mathematics. Right? So you need to know the foundational mathematics through which you can arrive at insights. And the closest field in classical sciences is statistics. Because statisticians have always tried to do this. Statisticians have always tried to take data, use a bunch of mathematics to come up with conclusions. Now if I do that at a massive scale, not just using statistics, but a lot of areas in mathematics, whether it's applied mathematics or optimization, applied mathematics. I can even use calculus for all you know. Doesn't matter what tool I use, but mathematical understanding, most importantly, it's not just about knowing some brute equations. It's about knowing the applied aspects of the mathematics so that you can combine the applied aspects of the mathematical theory and the mathematical equations with the practical aspects of handling data. Those are the two skills that you need to be a data scientist. Two foundational skills: programming knowledge, other is being comfortable with applied aspects of mathematics. Third, obviously, is you need to have fun while doing it, right? I mean, otherwise, what's the point in this? If you really like figuring things out, if you have that scientist in your mind, why is this happening? And is there something hiding underneath the hood here that I can unravel through all the mathematics and computational tools? Then you have like a terrific thing at your hand. So two foundational skills, one more of a behavioral skill that you want to have that interest to figure things out. Curiosity. Our kids have it in like tremendous amounts. As we grow older, we forget some of it or we leave some of it. But if you have that curious mindset to figure things out, you will enjoy data science.
Definitely. This relates to me a lot because when I was in my first semester of college, I was just building things out of the pleasure of trying to understand how can I crack this. Like I built like a pose estimation model, which would look at the video, it would tell the poses like the ears, the nose, and things like that. So that was always something that I was drawn towards. Many people ask me this question that, Ishan, I'm not from a tech background and I'm also weak in maths, as I talked previously. How can I get into data science? And is it even a possible thing for me to think about?
So let's again break it into two parts. One is somebody who doesn't know technology. Other is people who think they're bad at math. So people who don't know technology, right? Today, high school kids can learn to code. We have it in the syllabi of CBSE. Like I learned programming in my 9th and 10th class. This is almost like a decade, almost 2 decades back. So if a 9th class kid can learn, I think any of us can learn basics of programming. I'm not saying you need to be an expert programmer. The basic, think of programming as a tool at your disposal. You get data, you run some code, you understand what's happening. It's just a tool as far as data science is concerned. Don't be fearful of the tech being heavy. It's just about being persistent in your effort. Don't expect results to happen overnight. You need to give it a good 1 year. Let's be realistic about it. You have to give it a good 1 year of consistent and persistent effort. Now, that way you can become a decent programmer who can at least crunch data. The second part, I don't know mathematics, I'm bad at it. The answer to that is most of us were either not taught mathematics the right way or we just were frightened because of the complexity of equations. Most math education, unfortunately, revolves around equations, not about practical aspects. We all learned about the Pythagorean theorem, a square plus b square is c square. We were very few of us, there are only a small percentage of teachers who teach why we are learning this. So in data science, the most important, I use the word applied mathematics. So if you can learn the mathematics concepts from an applied standpoint, then sky is the limit. So even if you perceive and you think you're bad at mathematics, it's probably because you either did not learn or you're not taught the right way. The moment we learn concepts from a very intuitive grounding, from a very applied standpoint, where equations feel like poetry. This is what I tell in my class, that hey, all the diagrams that we see, they're the art of mathematics. The equations are the poetry. Because in poetry, you're trying to say great things, complex things in a very crisp fashion. Your F equals to MA is just in literally 4 characters. You're going to say so much about the physics of the world.
Right, right.
So equations are all about putting things crisply. But imagine if I had to put you back in that 6th or 7th grade, and if somebody taught you mathematics from a fun perspective, I'm sure you would bubble up and learn.
Definitely. This reminds me of Walter Lewin and H.C. Varma
Yes.
lectures in
Yes.
physics. Beautiful places to learn about applications.
Great
of physics.
teachers.
What are the differences between data scientist roles, machine learning engineer roles, and data analyst roles? Many people get confused about all of these terms. So is there any difference that they should think about? And what does a day in the life look like in these roles?
So let's first answer the first part. Broadly speaking, there are 4 types of roles. There is a data analyst role, there is a data scientist role, there is an ML engineer role, and some companies have this role called applied scientist or a research scientist. Again, the names and titles could be used interchangeably. Some people, these are not written in stone. These are approximate to what we see in the industry. Data analyst's job, fundamentally, a day in a data analyst job is they run a bunch of SQL queries, they write some simple data pre-processing scripts in Python, they get large amounts of data. They might be operating on terabytes or petabytes of data, and they make sense out of it using simple probability and statistics concepts, using simple plots. An analyst's job is to analyze the data and come up with important and interesting conclusions. That's the job of a data analyst. A data scientist, on the other hand, is one level above a data analyst. For example, a data scientist has a wider repertoire or a wider set of tools at their disposal. Whether it is techniques in classical machine learning, in deep learning, they just have more tools to analyze the data, and they can also predict what could happen in the future. That's what a typical data scientist does. A data scientist at a top product-based company, like a FANG-like company, is expected to know a good breadth of concepts and a decent depth in each of the concepts. The next role is machine learning engineers. So so we were on this trajectory, right? So you have data analysts, data scientists, machine learning engineers. Think of them as 50% software engineers, 50% data scientists. So typically for a machine learning engineer, you need to know data structures, algorithms. I'm talking about the best of the best companies. You need to be able to write production quality code. You need to know a little bit of time complexity, space complexity, little bit of productionization.
Efficiency.
How do you write efficient code, clean code, object-oriented code? So you need to know all that. In addition to knowing what a data scientist knows. That's your machine learning engineering. The 4th role is applied scientists. Applied scientists typically are people who are expected to have a lot of depth of knowledge, which means they should be able to take a cutting edge work, bleeding edge research work, and take it into their products that they are building internally. Of course, there are very few research scientists at companies like Google DeepMind, Facebook AI Research, Amazon's research divisions, who actually publish open research work. But those are few, right? So typically amongst these 4 roles, again, each role is important, trust me. You can't say, I'll only become applied scientist. Then who will do all the heavy lifting of data analysis?
Right.
Because I've seen instances where data analysts in my teams have created more value, monetary value, and actual great customer experiences because they found the insight by crunching through data, which an applied scientist could not find. So these are the spectrum of roles. Of course, research scientist being the 5th one.
How can someone get into these roles? Like coming as a beginner, learning all of these tool sets that you talked about, and then getting into product-based companies like FANG. So how can all that be done?
Okay, cool. So again, let's go back to what do you do in this job and what are the skills you need? See, the most important thing is the skills. Let's go back to that. You have to know programming. You have to be decent at basic programming. Right. SQL is mandatory because you're crunching data day in, day out. You have to know a bunch of, Python is the most widely used programming language. So you have to know basics of Python. You certainly have to know some libraries to do data pre-processing, basic statistics and things like that. This is the programming or the tooling side of things. On the mathematical aspects, you certainly need to know probability and statistics. Most people fear that. But if you learn it from a practical standpoint, then you have to know some foundational mathematics like linear algebra, calculus. Again, you require very little bit of integration. You mostly require differential calculus. Right. You have to have the breadth, obviously. You have to know a good chunk of these techniques. You need to know how things work under the hood. A lot of times I see this with people. They say, I know this technique called gradient boosted decision trees, or I know Dall-E, right, which is the algorithm that we're talking about, right. Or I know convolutional neural networks. They know it like a black box. What you have to know is you have to know every nut and bolt of it. For the top product-based companies, you have to know every nitty-gritty detail of how things work internally. Because only when you know how things work internally, you can actually apply it most optimally, and you're not going to misapply it or incorrectly apply things. Mm-hmm. Right? So the top product-based companies expect you to know inside out what's happening in each algorithm, but that alone is not sufficient. Along with it, you need to have the applied practical knowledge on how do you take this, if required, modify it to solve a real-world problem. Right. To put it simply, you need to know programming or the programming tools like SQL, Python, all of that. You need to have the breadth of knowledge, the depth of knowledge to understand what's happening under the hood. Most importantly, you need to know the practical aspects on where you can apply, where you can't apply. One of the most popular interview questions that I see, that I even ask is, if I say, what is your favorite technique? Or what is the technique that you have used in the most recent past? And I say, where does it fail? Tell me, where does it fail? Right. And most people struggle to answer that because they have not thought through that way. Or we ask, okay, in this whole model, if I remove this, what happens? Would it still work? If it doesn't work, why is it not working? These are actual real world questions that you have to understand. So to get into these fields, it takes time. Rome wasn't built in a day. You will not become a data scientist in a week. Let's be realistic. You need to put in effort. There is no escaping that fact. You have to put in 9 to 12 months of good effort on this. Focus on these skills. Don't skip on the depth. Don't skip on the applied aspects. So for example, I work very closely with students from top universities. They have great depth of knowledge. They know the mathematics. They have good breadth also. They are very good programmers, but they don't know how to apply things properly. The other side is also there. I see people who just apply it thinking it's a black box. When something fails, they don't know how to debug it because they don't know what's happening under the hood. So I'm also responsible for the whole design of the curriculum for the data science and machine learning programs at Scalar. So we said that every concept we learn it from the context of a real world problem. While solving that problem, for example, when we teach basic probability, we take the design of a COVID medicine or a COVID vaccine as a case study. And we said, now let's see how we can do it. We actually take original research papers of COVID drug design and experiments into the classroom and we say, imagine you're the statistician or the scientist sitting there. Tell me, is this drug working or not? Right. And you can change the lives of billions of people, right? So what we do is we start with a real world problem. While solving it, we explain all the mathematics and we write tons of code. We don't skip on the depth. I've seen people who say, we'll solve real world problems, but they skip on the depth. The moment you skip on the depth of knowledge, that guy can't figure out what will happen if something breaks down. Right. So we try to make that fine balance between breadth, depth, and most importantly, practical aspects. I mean, that has been the cornerstones of how we design the curriculum at Scalar.
It's really important. You know, when I was learning, did data science and machine learning, my senior in college said, just make a simple multi-layer perceptron without using TensorFlow or any other library. Just build it from scratch. And if you do that, then you know how everything really works from the nitty-gritty details of it. I
was just teaching a batch just last week. The exact same thing. We teach them backpropagation. And I tell them in the class, let's sit down and write it. The whole one class, a 2-hour class, is completely blocked to implementing a backpropagation, which is a multi-layered perceptron, from scratch. And then for the assignment, we put a twist on top of it. And then we said, now you solve the twist in the assignment. Because the moment you do it, again, if you see a lot of top universities, take Stanford for example, one of their assignments is implementing multi-layered perceptron from scratch without using TensorFlow or PyTorch, just using NumPy. That is important to understand the depth.
What are the free resources that one can use to like get a glimpse of this thing and really see if this is something that they're interested in, right? So what are those resources that you have found in your own experience to be gems available online?
Not everything is at one place. They're split. So for example, I really love the discussion forums on Kaggle. Right? Kaggle has these competitions with discussion forums. Those discussion forums are terrific to learn things like feature engineering. What data pre-processing should you do? And what tweaks can you do to your models to squeeze out that last iota of value? I still read them today. because otherwise I wouldn't be upskilling myself.
Right.
So that's a great place if you already know the basics. Certainly you can go to resources like MIT, OCW, Stanford University. All these universities have their machine learning courses. There's a small catch with this. Most universities, because they're very research focused, most of the curriculum tends to be research focused with very little practical aspects of it. Because the professor who's teaching is doing fundamental research. He's not building something for Google or Amazon.
Right.
So if you want to learn the foundational mathematics and depth, university courses can be helpful, but they can also be a little disorienting because you just see a whole blackboard of equations. So you have to be careful there. But there is a lot of value in that. Now, to get practical knowledge, again, breadth is available everywhere. Like, I mean, you know all the techniques. You can just go to Scalar's curriculum and you get all the breadth of techniques that you should learn. Programming, straightforward, there are tons of resources. Most importantly, for the applied aspects, take a problem, solve it. Better still, read other solutions on Kaggle. Spend time, read it, solve the problems, and that's the best way that I know. So the best resources are not at one place, but they're spread across. Of course, there are some terrific books, like there is elements of statistical learning, which is mathematically dense, but probably one of the best books written out there. There is Christopher Bishop's book on pattern recognition, which is great, but it gets mathematically dense very quickly because these are written for university students. So as a learner, you have to make that balance. So these resources do exist. You just have to put in time to get them through.
I think this is really important because most people out there, they open any tutorial on YouTube and they see like, TensorFlow.keras.dense.layer.
Oh yeah, so a lot of people think that if I know TensorFlow library, I know deep learning. No, you don't. You don't. We can teach a TensorFlow library to a 9th class kid.
Right.
It's not rocket science. You can do it. What is important is what is happening under the hood. How does TensorFlow's backpropagation work? How does the computational graph under the hood work for TensorFlow or Keras? Those are important stuff. And those are foundational. Because tools come and go. We implemented some deep learning stuff when I was at Amazon. Before TensorFlow existed, we implemented things from scratch. Now PyTorch is taking up, is becoming very, very popular. Right? So tools come and go. The foundations are very important. Foundational knowledge is critical. Tools, of the knowledge of tools is important, makes your life simple. But tools is not knowledge.
Right.
Tools are tools.
That's really interesting. I'll tweet that right now. So Srikanth, as we talked about the free resources, what is different in the DSML program by Scalar and why is it expensive?
Okay, so let's break it down. Typically the free resources are very widely spread and it's very easy for people to get caught up in one and lose track of the bigger picture. And a vast majority of our learners at Scalar are working professionals. They already have a full-time job and they want to upskill. They're very serious about it, but they neither have the time to go down a rabbit's hole and they want a helping hand who can mentor and help them. It's not just about teaching, it's also about mentorship, making sure they have great career transitions, etc. So at Scalar, there are a bunch of things that we focus on. First is we want students to come to the class. We make sure we do all the homework from the instructional org to make sure we give you the best learning experience in the 2 hours. We try to hire the best people from the industry. We compete with the MANC companies to hire great talent. And we take no shortcuts there because teaching and instruction is the core central thing for us. We spent so many tens, even hundreds of hours training our instructors because some of them came from industry. They may not have had teaching experience, but they want to teach. They're fundamentally teachers at their heart. So we have to upskill them. We make sure that everything that you're learning is aligned with what industry wants. So the curriculum design has been done, keeping industry needs, also keeping our learners' needs in mind. A learner doesn't have too much time. That's why we typically have 3 classes a week, each 2 hours long, right? So that's one aspect of it. Next, in the classroom itself, because our class sizes are also fairly sensible, that at the end of the class, any question you have is right there, right then answered by the instructor and it's resolved. And you also get to learn a lot from your peers. Because all of these people are working professionals, right? Each of them come from different backgrounds and perspectives. I have a physics guy in my class who is a quantum physics guy. He asks me questions that no other student can think of. I have somebody who is a data scientist in my class who asks completely different questions. And that helps other students think, oh, this can also be thought like this. So there is a lot of that peer learning happening through questions. And the instructors make sure that every nitty-gritty question that they have is resolved right there. So after 11, we still sit for like 20-25 minutes to resolve every question. If required, I sometimes sit even whole 1 hour to resolve everyone's questions, if it's a complex topic. Then we have a mentor who you can think of it as a buddy, who is there right next to you to mentor you, to guide you on this long journey of learning. And you have mentor sessions on regular basis. Some of them one-on-one, some of them in small groups, so that you can talk to somebody. A mentor is somebody who is a few years senior to you, who is actually a data scientist in the industry, and who comes from similar backgrounds like you. Like for example, imagine if I'm somebody who is at a services company and I want to become a data scientist at a product-based company. We give you a mentor who has similar persona, who has done that exact transition in the past, so that they can empathize with you. And we have seen that this mentorship thing is extremely helpful. Because if you have somebody whom you can talk to and get that personal feedback, that enormously improves your outcomes.
Right.
That's the second part. The third part obviously is our careers team, which makes sure that any student who has been diligent, who has gone through the whole program, has a great career outcome. So these are some of the things that we focus on. These are the most important things that we focus on as part of the curriculum, as part of the student outcomes are concerned. Now coming to the pricing part of it. The price is proportional to what we offer. Right? At the end of the day, all of our learners are working professionals. They're short on time. Some of them have families that they have to take care of. But all of them are passionate about learning data science and upskilling. So we value their time. And most importantly, the whole curriculum is designed with the best instructors. Now imagine if we at Scaler, the instruction org at Scaler, is competing with FANG companies for talent. And if we want to hire a senior guy from Microsoft or Google, it doesn't come cheap. So we told ourselves a very basic equation. If we want to create the best program with great instruction, great mentorship, great career outcomes, I don't want to take any shortcut.
Right.
No shortcuts whatsoever. I want to get the best teaching, best engineers and scientists to come and teach here. How much does it cost? While it may seem little pricey for some people, look at it the other way around, which is if you take into account the EMI options, the no-cost EMI options that you have, think of it as an investment in your career, number one. Equally importantly, look at the career outcomes that you can have if you're diligent in the whole program. If you're persistent, the career outcomes can be enormous, that the fee looks like minuscule then. Right? So if you're serious about learning, if you're willing to put in that effort, then I think the fee is not such a big restriction for working professionals. Right. And we need to have that price point because that helps us make sure we are not compromising on any aspect of the program. Because if you reduce the price, we will have to compromise on some part or other part, which we don't want to.
Right. It's really important. The value derived from this program is much more than what the fees is going to be like.
Yes. The ROI for people who are persistent and consistent is significantly high.
One of the best parts about the program that you talked about here is that we have people who can solve your doubts and there are peers who you can talk to. That's what I felt when I was learning about DSML, was that I felt unmotivated sometimes, or I felt stuck. What do I do now? And I used to just go through hundreds and hundreds of sites just trying to figure out what went wrong, how can I fix this. And I would realize there's some small semicolon that I left out.
So we also have an army of teaching assistants who are just a call away.
Right.
So you could just come to a portal and say, hey, I have this question. I want to have a quick call. A turnaround time is very, very small. A teaching assistant joins your call and he will help you. He will not give you answers. Like imagine if you're solving an assignment. He won't give you answers, but he'll point you in the right direction.
What is the scope of data science in the future? People ask this question because, like, let's just say they spend 1 or 2 years learning about data science before they learn about mathematics and programming and then DS. They want to be certain that for the next 5-10 years, this is a hot field. Like, to 2014, I saw that newspaper report saying that the hottest job of Silicon Valley is data science. I was in 9th grade back then. I was like, I want to become this. This is what I will do. And the way to do that was IIT. That's how my IIT race began. So like, what's the scope going forward in 2022?
So with what, again, we can never predict what happens 20 years from now. I'll make a fool of myself if I try to predict. But at least from a few signals, right? For example, the amount of data that we're collecting has increased enormously. The mathematical techniques that we have are simply exploding. The tools that we have, whether it's programming tools or otherwise, right? Or hardware is exploding, which means we'll only be crunching more data, right? So everybody has data now. There is no scarcity of data. There is tons of data, and we want to crunch all of the data to have insights. And if you even observe just the last decade, imagine the explosion of internet because of 4G, thanks to Jio. Imagine the explosion of data that we have. Now, if the same trend continues, I think just like the way software is eating the world, right? I think this is a very famous quote from a venture capitalist who said, software is eating the world.
Mark Andreessen.
I think Mark Andreessen from A16Z, right? So if software is eating the world, I would say data science is just its sister in software. It's just a sister, it's just a ad hoc, it's an additional tool that together they can create much more magical systems. Software is certainly eating the world, but data and data science and data tools are just the sister for the whole software development to do much bigger things.
Right.
So from the current trends, I don't see this slowing down at least for the next 5 to 10 years. But let me also warn you that just like in the early 2000s, anybody who could write a prime number code in C programming told that I am a software engineer.
Right.
Today, I see people who can just do pivot tables in Excel who say I am a data scientist. They are not. There is also, see, it's just market dynamics at the end of the day, right? So when people say I'm a data scientist, you have to always ask, what do they know? What have they built? How deep do they know it? Because somebody who is just writing 5 lines of C program or 5 lines of JavaScript program can say I'm a software engineer. They're not. So because everybody says data scientist is a fancy job, now everybody wants that in their title, whether they know it or not. So we have to be also cautious of that. Just like the way the word software engineer was misused and overly used in the early 2000s, the same thing could happen in the 2020s.
I have my senior in college as well. He got offers from Google, Flipkart, Goldman Sachs, Myntra, and a bunch of other companies, right? He negotiated both the offers. He used to show the offer of Goldman Sachs to Google, to someone else, and he finally got a Google job with a nice package. So obviously, as you were saying, that people who are really great at it get headhunted by all the major companies.
There is no dearth of good roles. I talked to the teams that I worked in the past, and they're like, Varma, if you have some good people, please send them our way. Because we're still struggling to hire good people. Because either people know some basic depth from a university course, or they just know things as black boxes. They don't have a good balance of both.
Going off on a tangent, do you think that AI and machine learning in general will eat away jobs that we currently have, or is it going to automate creative jobs that people right now have? Like Canva came up and people were like, will this destroy the lives of
I love
designers?
Canva.
Yeah, it's amazing.
So to answer your question, there is a very nice analogy. When modern automobiles came into existence, the whole horse buggies industry died. But was it better for humanity or not? Of course, if you keep the greenhouse emissions aside, it made people's lives more efficient. At the end of the day, we as a civilization are going towards more efficiency and hopefully more happiness. Hopefully. I said the word hopefully because I don't want people to get on the treadmill of always more efficiency. So having said that, AI and data science will replace some jobs. That's a reality of it. Let's not fool ourselves otherwise. But I think it will create far more jobs than it has decimated. That is also equally important. This is a property of every breakthrough technology. This is not just AI. It happened with automobiles, it happened with internet. Because do you see any travel agents today? No. All the travel booking, because everything is done online. Right. You don't require a travel agent. But it has made lives better, right? So the whole idea here is AI will decimate some jobs, but it will create far more, many more jobs. Of course, to get these jobs, you need slightly different skills. You need to upskill. There is no denying that fact. And I'm hoping that it will create more prosperity and more efficiency in the systems. Now, coming back to creative jobs, it's a very nice question. I think you're referring to DALL-E, image gen, etc., right? Let me ask you this question. Did Adobe Photoshop kill artists? No, it made their lives much more efficient. A DSLR that we are shooting on right now, it has made anybody anywhere create great video production systems. And I've seen people who made their movies on an iPhone, which are world class. Today, a high school kid with a great story in his or her mind can truly create great work just using an entry-level iPhone. They don't even require a high-end iPhone or even a decent Android phone. So technologies like smartphones, internet, 4G specifically in India, or Adobe Photoshop for artists, they have democratized things. So for artists and in general people, I would say that these AI-assisted art, which is your DALL-E 2, image gen, all of these, will explode the potential. I won't be surprised tomorrow if a high school kid can create a better piece of art, whether it's visual art, whether it's movies, whatever, or even sculpture for that matter, than an artist who has been in it for 20 years. Which means we're democratizing it. We are giving a new tool. We are not replacing human creativity. Even for DALL-E 2, we have to give the human element to it, which is the text. Let's not forget that. So we are changing the dynamics of art creation. Today, I can't paint. I have no clue how to paint. I'm terrible at it. But using a tool like ImageGen, I can quantify my thought process on what I want. Suppose I want a small painting. Suppose I can't afford a world-class painter, but I can just give some text-related cues. Let the AI paint it, and there could be a robotic system that paints the whole thing with oil, with oil colors. Imagine the new markets we create because of it. So I think artists, because we specifically talked about artists, they have to be ready to embrace these technologies and level up, because a high school kid could compete with them tomorrow. That's the game.
What is the importance of formal education in case of data science, and more importantly, master's degree is what many people are confused about. So what do you think about this?
Let's talk about the master's degree specifically. See, at the end of the day, any degree is a signaling effect. If you have a degree, it shows that you went through, you put in these many hours of effort to earn the degree, and you have certain knowledge of concepts. So degrees are basically about certifying that you have put in the effort, and it's about a certification. Different universities have different levels. A Stanford or an IIT might say my bar is higher. So people have to have put in this much hours of effort, and this is the skill that they have. That's why I'm giving them a certificate. In data science, if you can showcase your skills, degree is a good to have, not a must have. I would argue that they're not mandatory, but they're an icing on the cake. They're good to have. If you're anyway putting in the effort, get a degree. And if you don't want to get the degree, that's also okay. Just make sure you're projecting your skills. For example, you have a great GitHub profile. You have, let's say you have a bunch of projects which are available on GitHub. You write a good technical blog on Medium. You make short video demos of the AI systems that you have built. That's your portfolio. That's your certification that, boss, I've done this. I've solved these problems. So at the end of the day, as a hiring manager, what I would look for is a proof that this person knows it. The proof can come from a degree or can come from your portfolio. Doesn't matter. If you have both, that's better. Just extending on the master's question that you have asked, the reason we created Scalar University, where again I'm responsible for curriculum, the coursework design, etc. The reason we created Scalar University is because our students are putting in as much effort as they would in a regular master's degree. And when we talk to students, they said, I'm anyway putting in the effort, can I get a degree out of it? And we said, this is very logical. So that's why we started Scalar University. And at Scalar University, we wanted to have complete freedom on curriculum, because we don't want to be dictated about curriculum by anybody except the industry. So at University, people go through our concepts, go through the assignments, they have proctored tests, they have Viva, which is nothing but mock interviews. And through that whole program, for the effort that they are putting in, they are getting a degree.
Just as you were talking about projects, what are the type of projects that people should create that would both impress the person who's trying to hire in terms of breadth and the depth of the person's knowledge about
Very good question. Very good question. So I see a lot of people doing cut and paste, copy paste jobs. A recruiter can read it in 5 minutes. So my suggestion is this: at least try to have 3 projects, 2 to 3 projects. One pure data analysis project, one using classical machine learning, one using deep learning, so that you are showcasing the breadth, number one. For the depth, for every project that you do, go full depth. When I say depth, it's not just about applying a bunch of, it's not about trying some 10 algorithms. It's about debugging why those algorithms did not work, and how can you prove that this is the reason why they are not working, and how do you fix that? I don't see a lot of people doing that in their projects. And this is what the interviewer asks. If you say, hey, I have built so-and-so image detection system. For example, you're talking about post detection, right? In an interview, if you bring that up, you'll say, where does this fail? And when it fails, how do we fix it? And why is it failing? And if you can cover that in your technical blog, that shows your depth. So that's why in our Scalars programs, from the very early days, from the time they learn basic pandas, basic NumPy, we start with very simple data analysis projects. When they learn probability statistics, we even work with a bunch of very nice companies that share their problems and their data sets with us. And we bring it in the classroom and we say, let's solve this together. Imagine you're working at this startup as a data scientist. Let's solve this problem together. So we have almost 70 to 80 projects that we go through in increasing complexity. As you keep going to the end of it, we actually make people productionize these systems and deploy them using simple deployment tools that are publicly available on cloud. And we say, showcase your work. What better way to do that? So my suggestion to anybody who is building a data science project is, don't take it lightly and don't just do it to fill your resume. I see 95% of people doing that. The simple rule is pick wide spectrum of problems, one pure data analysis, one classical ML, one deep learning. When you write the technical blog, try a bunch of techniques. why is it not working? Then you have a very good set of portfolio. And if you can make a 5 minutes video of it with everything working, what better way?
Wonderful. Thank you so much, Srikanth, for joining me here. I hope the audience got value and got to learn about DSML and how can you get into this field. And hope you enjoyed this conversation as well.
Yeah, great. Again, nice to see people like you, youngsters who are full of energy. And I mean, great discussion.
That was the video. I hope you got to learn something new from this. If there's one major learning that you had, let me know about that in the comment section as well. You can also check out Scalar Academy with the link in the description. You can follow me on Instagram at Ishan Sharma 7390, and I'll see you in the next one. You can share this video with your friends, hit the like button and subscribe. I'll see you again.